Thanks everybody for joining us. We are really excited to be wrapping up a full and very busy month of machine learning. I hope that everybody has been able to take some time during this month to maybe take a look at some of the Kaggle courses, to think about just concepts of machine learning and artificial intelligence, to join us in some of these sessions that we've been having all month long, read some interesting articles, whatever. This whole month, we have spent an entire month really thinking and focusing about the opportunities that machine learning provides for us, especially here in Hawaii, as well as globally. So it's been, I know for me, I've gotten a lot out of this month. I hope everybody else has as well. And I think our speakers that we've had so far have been really super interesting. Kaimi, back in week number 1, had a lot of really cool stuff to share with us about things that they're doing actually here on island, and programs that they're working with interns, which was really interesting. And 2 weeks ago, we had Maddie. She was phenomenal. She talked a lot about some really cool stuff going on with recommending engines and predictive analysis, and just lots of really cool cutting edge stuff. So that was really neat to watch her demonstration. Of course, we ended up taking a last week off because of some other issues, but this week we are wrapping up our entire month, and I'm really super excited that we have a guest speaker with us today, all the way from Brazil, other side of the planet almost from here. Definitely a 5-hour time zone change, right? So we appreciate you joining us, and I think some of your countrymen are here with us as well. It looks like we've got some other folks that are joining us from Brazil also. So thank you so much for spending some time with us today. Gabriel, would you like to go ahead and introduce yourself to us, and I'll stop sharing my screen.
Sure. Okay. Nice to meet you, everyone. I'm Gabriel. I'm a data scientist here in Brazil. I work in a major consulting firm, and I'm going to tell you a bit today about my journey into data science. I'm going to talk a little bit about how to develop result-driven AI. So how can you develop AI systems that will generate results? So don't just stay in the modeling part, creating models and creating predictive systems that won't help in actually problems of your community, of your company. And in the end, I'm going to talk a bit about how to start in AI and some tips that I have.
Awesome. Sounds great. And folks, if you have any questions along the way, please feel free to drop them in the chat. We can monitor those as we go along, and super excited about your presentation today. I will let you take it away. Thanks a lot.
Okay. So as I said before, I'm going to talk a little bit about result-driven AI and what are the best practices to really develop systems that are relevant and that will create results for your company, for the people that you're developing those models for. Okay, so we'll start talking a little bit about myself. My name is Gabriel. I'm from Brazil, especially Belo Horizonte is my city. I'm 23 years old. Today, I work as a lead data scientist at Falconi. Falconi is the biggest consulting firm, management consulting firm in Latin America. We have almost 40 years of experience generating results for our clients with management practices. And a couple of years back, we started to bring AI and data science into our solutions. So we have management and technology solutions now that help empower our clients to deliver better results. Talking a little bit about my company, we have our professor Falconi. He came from Japan with some techniques of management and developed a methodology that helps a lot of clients with their management. And he has a very famous book, even outside of Brazil. I didn't get the name in English, sorry, but it's a very good book talking about management, and the true power is the name of the book, of the management techniques that help to generate revolutionary results. And what I do is work with clients, bringing those management knowledge and data science knowledge to help deliver results. Okay, I'm also a Google developer expert in machine learning, and I'm a master's dropout. I started a master's degree, but it wasn't really the timing for me, so I dropped out, and I can talk a bit more about master degrees if you guys have any questions later. Okay, I'm going to tell you a bit about my journey because it's a journey a little bit different from the people that come into AI. There are a lot of different backgrounds that you can come, but I started from a business career. So I worked in a consulting firm with mainly business related subjects. And I graduated in business in my local city. So business is not the most common way to come into AI. Most people come from a more engineering or computer science or statistics background. But I'm here to show you that you can come from any background and still be able to work in a high level with machine learning. Okay, so how I started. So I didn't even know how to code when I started. So the first thing I had to do is learn how to program in Python. So I started coding on the data camp and learning a lot about the main libraries, how to use them, how to apply them to real data. Then I went to Coursera and I did a couple of courses in machine learning. So I would start to have some practical knowledge of how to develop models. And then I entered my company as an intern. When I entered, I knew a little bit how to program in Python and the techniques, the high level techniques of machine learning. And it was the best thing for me to start working with it so I could really apply it and deepen my knowledge in all those algorithms in real life problems. And it was the best thing to start early in my career as an intern in a company. Then I did a boot camp, Le Wagon. It's a French school, but it has campuses worldwide, and it was really good. It went very deep into all the steps between gathering data, programming in Python, data engineering, model creation, deep learning, machine learning, statistical knowledge, and even some cloud computing. Then I kept working on Falconi and started to learn a little bit more about Google Cloud technologies, how to use Google Cloud and the data tools, the machine learning tools they had to deliver those systems and those models to our clients. And I did my machine learning certification last year. So I did the test and I passed. And this year I became a Google developer expert in machine learning as well. So this is my journey. I like to show this because it helps people to know where you can start and how are the paths, what paths can you take to start and to really work with machine learning. And in the end, I'll show you some tips as well on how to start and how to find your own path. Okay, so now I'm going to talk a little bit about result-driven AI. This is a concept that is not very much discussed in the courses. So most of the courses and most of the courses you do online and even on universities or YouTube, they focus a lot on the technical knowledge of how to create very good models to predict the thing that you want to predict, how to program the best code possible to work with the data that you have and feed it to the model. How can you deploy this model in the cloud with the best practices? But all that is worthless if you don't solve a problem that has some importance for the thing that you want to solve for your company, for your life, or for your community. So here I'm going to bring some techniques to help with result-driven AI. So AI that generates results. Okay, going into machine learning systems, we have all these major structures here that compose a machine learning system. The yellow part is your machine learning code, where you do feature engineering, train a model, and have that model making predictions. So a machine learning system as a whole is composed of much more structures and uh, much more things that compose from production to data. So we start from the data part, where we have to collect the data we want, verify it, extract features, develop a pipeline that makes this data come into your model in automatic fashion. And then we go into the production steps, where we have to serve that model and make that model deployed in order to make predictions in a regular basis, with some analysis tools to monitor that model, some infrastructure to make that model be able to scale depending on how many predictions you want to do. And we have some process management tools as well that connect that model into a process and into the system that you want to create. So a machine learning system is not just the Jupyter notebook where you get the data, do some code to clean the data, train a model, and have the file of that model in your computer. No company does that. They experiment in notebooks, but when you want to have a machine learning system working in your company, you can't have it in a notebook. You have to have all these structures working together to deliver a very good machine learning system. So this is the first part that I wanted to talk about, is those giant structures. They are, we can talk, we would need another talk to talk specifically about all of them. But here, this is just to give some perspective of what the ML code is in a machine learning system in the real life. Okay, but still, we can create this perfect machine learning system with the best possible model that has 99% accuracy, and still this machine learning system is not, it's useless. It doesn't impact on decisions. It doesn't help to generate results. And when we talk about results, we're talking about monetary results, or even if you work in a nonprofit, helping with the goal that your company or your community wants to achieve. So results is achieving better your goals. So you can create this machine learning system that still doesn't impact on those decisions and on those problems. It doesn't solve the problem that you want to solve. You are really good at predicting something useless. So that's why we have to align our machine learning system with 3 pillars here that are people, processes, and data. You can't have a machine learning system if you don't have people that are going to use and that are going to make decisions based on those predictions. You have to have processes. So what is the process in your company? What is the process in your company that you're working with to deliver? It's a purchasing process. It's a churn process. So we have to have people and ways to work with those predictions and the data as well to support those machine learning systems. If you don't have the necessary data, you can't have the machine learning system. So here, I want to bridge the gap between those 3 pillars and the machine learning system, and show you some tools that we use to make better machine learning systems that will be successful and will generate relevant results for your company. Just to mention one more thing, there's a study that about 85% of machine learning projects fail. And the 2 main things that these projects fail is because, first, the people don't create the structure with all those macro structures here that I showed. So people focus only on machine learning code and not on how we're going to bring the data and deliver these predictions to decisions, and also they don't focus on how to make all those pillars work together with the machine learning system. So 85% is a lot, and these tools, they help to avoid those 85% chance. Okay, first I'm going to talk about the CRISP DM. This is the cross-industry standard procedure for data mining. Data mining is the old name for machine learning, when a couple of years ago it was called data mining. And this is a process that is a cross-industry, so it works on all industries, and it's a standard procedure. So if you want to do a project with data mining or machine learning, you need to follow this procedure. So what this procedure tells us, it starts with the business understanding. So we have to have a deep business understand the problem that we want to solve, and then work together with the data that we have to find a possible solution and to find the data that you have that you need to solve that problem. So we have arrows pointing in both directions, because we must always look at the business, look at the problem, and try to find the data that will be relevant to that problem. Then we prepare our data and create models. So this preparation and the modeling have also arrows pointing in both directions, because we try a model, then we find that we need more data, or we need data in a different format, or even we need data, other features, and we need to bring more data. So we have arrows going back and forth. Then we create the model and evaluate that model. And evaluating the model is not only seeing if that model is predicting with high accuracy, for example. It is also that big arrow going back to business understanding, seeing if that model is really solving the problem of that business. And then we go into deployment, that is making that model available to solve the problem. This is a procedure that is used on a lot of industries until today, even today. But there is a modern approach to this cycle and to this procedure that is called the CRISP ML. So here we have the main difference in the last two blocks, in the last two circles there. That is the deployment part in the CRISP DM, that we didn't go a lot deeper. So CRISP DM doesn't go deep into what the deployment part is, and it's a very important part. So the CRISP ML goes deeper into how we develop a model and make the operations of that model. So here we have three big steps that are business and data understanding, model development, and model operations. All these phases, they work to bridge the gap between what we want to develop, the problem that we have and we want to solve, and how is that problem going to be solved. So the first part is the business understanding. What is the main objective of those cycles? The main objective is, first, understand really well the problem that you want to solve. So you have a problem, you have an idea on how to solve that problem. You see that there is a use case for machine learning, and then you try to connect the solution that you want to the problem. So the machine learning solution with the problem. Then when you do that, you start developing the data set. So you start building what kind of data, what are the data needed to solve that problem and to create the model that you want. And then you experiment fast. So you create simple models to try that solution in a simple manner. And lastly, we find the potential gain with a simple solution. So we make a lot of experiments fast, then we find what is the possible gain of that solution. All these in this initial cycle. When we have a solution validated, so here we can call a proof of concept as well. We create a fast proof of concept or minimal viable product to the solution that we want to create, really focusing on how we're solving the problem, not on what models are we using. So we have a couple of tools that we use to help mainly on connecting the data to the problem to the prediction task. So a canvas is something, we have the business model canvas that we use when you want to open a new company. So you we we uh, we can use the same concept here for machine learning. So we want to create a machine learning system. We have the machine learning canvas where we start with the value proposition. So we find out who is the end user. So what who are the people that are going to use this model? What are their objectives? How are they benefiting from your machine learning system? So this focuses a lot on the pillar of people, of how the people that work on the processes and that make decisions in your company can use these machine learning systems that you're building to make better decisions and generate better results. So we start with the value proposition, then we go to the rightmost part, and we find out what data are we using, what are the data sources, what features do we want to use in this model, and how many models we will need. So a machine learning system doesn't have to be only one model. We can create multiple models to solve a problem. And in the other side, we're going to look at the prediction. So what's the test that we want to predict? Is it classification? Is it a regression problem? And what decisions can be made with those predictions generated? So what decisions are the end user making, and how are they making better decisions with those predictions? Then we look at how we evaluate the model. How often do we make a prediction? So are we doing it real time? Are we doing it daily based, monthly based predictions? So this looks at the whole system of and how it will work, not only on the model part. We look at the data, we look at the predictions, we look at the decisions and the value that this creates. So this is a really fine tool. This tool helps a lot with the 85% projects that fail, just by using this in the beginning with the people that are your end user and your stakeholders. When you align everything that you want to create, you can kill a project before it starts when you see that the decisions that these predictions are bringing are not relevant. So I recommend always, when you start a machine learning project, to do this machine learning canvas in order to align all expectations, align everything that the model will bring, and think about the whole solution before starting to dig in a data set and create the best model that you can with deep learning, with recurrent neural networks. So this part in the beginning can help a lot to avoid the 85% projects that fail. Okay, and another thing that I really like to do in this first cycle is a backtest. So after you iterate, you create your machine learning canvas, you see that the solution is valid, you should develop it. You can create a fast MVP, and with that MVP, you can calculate how much that solution could benefit the company if it were implemented in the past. So I brought an example just to show you that if we use the model in the past, if we use this MVP in the past with a prediction rate that has a low quality because you created a fast model, a minimal viable model, and if we use that minimum viable model in the last year and predicted about 60% of the churn is, for those that don't know, is when a person leaves the company, stops being a client of the company. So if we predicted in the last year 60% of the churn using that solution, what economy and how much would this impact our business? So this is a way that you can easily see if a simple solution could have helped a lot in the past. So this solution probably will work very well in the future. And when we develop a model that's better, that has a better quality, we can even have a bigger impact in the future. But just by this small MVP, we could have had a lot of impact in the past. So this helps a lot on how to validate and see if your machine learning system will really be relevant and generate results in the future. Okay, so going into the second cycle, here we talk about the development part and the model operations part. So here we develop the data engineering part. So how are we going to get the data that we want and connect it to our model in an automatic way? Then we go into the machine learning model engineering. So we create a pipeline to train our model with that data, optimize the hyperparameters, test a lot of different models, and evaluate them. And if that model has a good quality, we can deploy it. So we can release the model. This can happen in an automatic manner. So we can collect data, test multiple models, and if the model exceeds a threshold, it can be deployed automatically. Then we create the operations for that model. We create the infrastructure needed to have that model working in the web, in the cloud, and then we monitor that model and keep a maintenance on that model. This cycle goes back to the data engineering and the model engineering, because we can always look here at a few concepts. If we can monitor if that model is going to a lower accuracy over time. So we train the model today, it's operating for 6 months, and we see that after these 6 months, the model's performance is decreasing. So where our accuracy, for example, is decreasing. So we can monitor this real time and trigger automatic training for that model in order to train with the newest data available and deploy it automatically. So this is really important. So this model development and model operations, and a concept that comes a lot from software engineering projects, that is continuous integration and continuous delivery. It is also applicable here in a machine learning system. So a continuous integration, CI, is basically versioning our code and testing it automatically. So we have always versions of our code and code that's being unit tested all the time. And continuous delivery, that we build, test, and release these new softwares and these new updates on an automatic manner as well. So machine learning operations, this CI and CD are called subjects of the DevOps, the development operations in a software engineering project. But when we talk about machine learning, we talk about ML ops, so machine learning operations, and we bring a third cycle here that is called continuous training. So this is what I was talking about before. We are always monitoring the models that are on production. We're measuring the accuracy, and we're measuring the relevant metrics of that model, and we're retraining and deploying that model, serving that model in an automatic and continuous way. So in a machine learning system, we have to have all these three CI, CD, and CT working in order to decrease the chance of failure of a project and to have the best possible solution working in our machine learning system. Okay, so this is the crisp ML. We went from the business and data understanding, just like in the crisp DM. We validated our solution. We measure we did the ML canvas. So we aligned all the solution and we ideated how we're going to solve that problem and what decisions are we making better with our prediction machine. And we validated in an MVP manner if our solution would be valuable and would have a relevant impact in the past. So if we validate that in the past, it would be good. we should continue to develop it for the future. And then we go into the model development and model operations that we try to automate and monitor our pipelines from the data to the machine learning to the predictions in a cycle that is always redeploying and reevaluating everything that's on production. So this helps a lot. Also, this brings the people and the processes together. So when we iterate over the business data understanding, those two pillars are really connected with our solution. And the data part, we're looking a lot on the model development and model operations part, where we are always monitoring from some concepts like data drift. So when we talk about data drift, means that our data has changed its distribution, or a concept drift, when we have the concept, the thing that you wanted to predict and the thing that you're trying to solve is not relevant anymore. So when we try to bring those monitoring to monitor those in the model operations part as well. So this really helps to bridge the gap between our pillars and have a relevant machine learning system that will generate results and will have an impact on the thing that you want to have an impact, or your company, community, etc. Okay, so after that, I'm going to give you a few tips on how to start in AI, and a few tips that if I would start all over, I would start by these things. So the first thing that I want to share is immerse yourself in AI. This was a thing that helped me a lot, not in the beginning because I didn't immerse so much in the beginning, but when I immersed myself in AI, I started to see a lot more opportunities, a lot more of viewpoints, and how people see AI and see how you can study, how can you impact, how can you work with it. So when I talk about immersing yourself, I'm talking about watching videos, watching movies, listening to podcasts, reading books, reading articles, everything that has AI. If you're connected with it, you will have much more knowledge and different ways of getting that knowledge. And this will help you much more than just studying by some source or just having a few hours on your day to look at it. If you're watching a movie, try to watch a movie about AI. Try to see how that is relevant to what you're studying and how that is relevant to the future, and to how you will work in the future with that. So immersing yourself really helps, and is my tip number one to anyone who asks me how to start with AI. The second thing is how to learn. So I like to do 3 steps when I'm studying something. I like to first study it. So I search for knowledge on, here we have different sources. We can go in a YouTube video, in a free YouTube video. We can look at courses on online courses. We can go into a university and try to learn and try to do a more extensible course there, or even a boot camp. So studying helps a lot, but is not enough. So just listening and maybe writing and doing some passive learning, you're not fixing the content so much. So the thing that helps a lot to fix more these things that you're studying is applying it to real problems. So you studied, for example, decision tree classifier, and you understand the algorithm, you understand how to implement it in Python, and when you apply it by yourself, you're really learning it, because you're going to have some struggles implementing it. You're going to have to solve a real problem with that algorithm. So you can go into Kaggle, for example, find the Titanic problem, the Titanic competition, and try to predict using the model that you have that problem So you can connect the algorithm with the real life problem. And if you want to go one step further, and this is the best way that you can learn something, is teaching someone what you did and talking to someone about what the algorithm does or how you're solving that problem. So this I like to do a lot, with especially median articles. So you study some algorithm, you apply it in a real life data set, and then you write about how you applied that algorithm and how you're solving that specific problem on that data set. So you're teaching someone, you're explaining to someone what you did, and this helps a lot to deepen your knowledge and to understand more about what you studied in the first place. You can also do it with a community, so you can teach a community, try to teach someone what you did, or you can do a YouTube video. But the thing that I like most personally is writing about it on Medium. This is also great for recruiting. So when you when you create those projects, right, you do some projects with the things that you studied, and you write about those projects, you start to create a portfolio of your projects and what you know and how to apply it. When you have those projects on GitHub, for example, and on Medium, this helps a lot of recruiters to find you and to validate your knowledge. So if you have a portfolio of your projects and of the things that you learned, this will help a lot to get your first opportunity to work with AI. And my last tip is start looking for a job as soon as possible. So the portfolio helps a lot, but if you can start today without a portfolio, start looking for a job, because real life problems are very, very different from the ones in Kaggle. So when you start working with AI, you can really improve yourself. You have a much higher chance of being of going faster than someone that is not working with AI and just studying. So if you start applying those things that you're learning in real life, you're going much further. So if you can, start looking for a job as soon as possible. These are my tips, and hope you like my talk. If you have any questions, I'll take them now.
Thank you, Gabriel. So one question right off the bat, because you said real life problems are really different from Kaggle. That's scary to me because I've only experienced Kaggle so far. So um, do you have any recommendations for transitioning out of this kind of Kaggle environment that we've been playing in all month long to looking at seeing the real world problems out there and trying to figure out how to construct a project around that? Where do I, I'm a rookie, where would I even begin trying to figure out how to set up a project like that?
Perfect. That's a very good question. There's something here in Brazil. I'm not sure if it's worldwide, but we have something called a hackathon. It's an event that a lot of people join to solve a problem, to try to create a solution to a problem using code. And there's a lot of hackathons with machine learning problems. And working with that, you're working with real life data. So the thing that is most different from Kaggle to real life is the data, how you get that data, and how do you connect the problem to the data. In Kaggle, you have already the connection made. So if you have a lot of data in a company and a problem to solve, connecting those two is really different than getting those two connected from the first place. So trying to solve real life problems, if you can find a data set that's relevant for something in your life or in your community, and try to do a project end to end with some people as well, can come a lot closer to real life problems than on Kaggle. So this is the main gap between them.
That's a great suggestion. And when you mentioned hackathons, that reminded me that here locally in Hawaii, we have our Hawaii Annual Code Challenge. And, this might be an opportunity here in Hawaii to for folks that are interested on island to participate in something like that that can contribute to that community as well. And I see in the chat we also had a suggestion for opendata.hawaii.gov as an opportunity for people here locally to find data sets that are relevant to our communities that we might be able to use to begin building out those models. So thank you for sharing those tips as well. Does anyone else have any questions for Gabriel? Please drop them in the chat. Let's see. Another question I had was about, for folks that might be very, very early in this learning journey. You already talked about how to get started in AI and how to study, but is there a particular programming language or tool or something that you would really recommend for absolute beginners to start with?
Okay, that's a very good question. And yes, Python is the most used language in companies to work with AI. So I would recommend the first thing you should do, and the first thing I did in my journey was learning Python. So Python is really easy to learn. It's a very friendly language, and you have a lot of free content in the internet, so mainly YouTube. So if you can start by if you need to start by a complete beginner, you should start with Python.
Thank you. That's a great recommendation. I appreciate that. Anybody else have any questions for Gabriel before we let him go? Pollyanna also had a suggestion that there's a good YouTube series called The Age of AI. That might be a good one to check out. Laurel asks a question, Gabriel, which metrics should be used to offline evaluate a model before deploying it? That is a great question.
That is a great question. Thank you, Laura. This depends a lot on your problem. So when we talk in the machine learning canvas, let me go back there. On what are the metrics that we use for offline evaluation, we're talking about finding out the best metrics that we can use for offline evaluation. So if we're doing a classification problem, we should try to see if recall or precision is more relevant. So is it more relevant to predict all the things that happened, or is it more relevant that all your predictions are correct? So these kind of trade-offs depend on what problem are you solving. So if you're solving a problem that, let me think on an example. If you're trying to predict if a patient has some disease by looking at some X-rays, so if he has a broken bone, you have to have a better recall. So we can't make wrong predictions. We can't let a real problem, a real example pass as a wrong prediction. So we have to make the right predictions based on the problem. So if we do a lot of predictions, if we do a lot of false negatives, if we do a lot of false positives, actually, if we predict that this bone is broken, but it's less problematic than predicting that the bone is not broken and it is. So we have to align those things to find out which are the best evaluation metrics, and also some deployment criteria like what is the size of the model. We're going to deploy it on the cloud or on device. If it's on device, it has to have less than, 200 megabytes. And so we can get those metrics as well here. But it depends a lot on the problem and on the method that you're using.
Yeah, I totally agree. False positives and false negatives have very significant implications. Sometimes you want to lean more towards one or the other, depending on what your outcomes are. But definitely mahalo for that insight. Okay, thank you so much for your presentation today. I really, for me, this was really interesting to see these life cycles, and I loved your illustrations. By the way, those were really helpful for me. I'm a very visual person, so thank you for that. I just have a couple more slides that I want to share. I know our time is almost over today. Let's see, this one right here. So this is what we've been working on all month long for the purposes of this particular study jam. And again, these are in Kaggle, which we just heard is maybe not ideal, but a good place to begin, right?
Yes, it's a very good place to begin.
So whether you've had time to participate with us this month or not, this was the program that we've been working on all month, and you can do this anytime. It doesn't matter that September is over. If you haven't had time to jump in and play with that, please feel free. What's great about Kaggle that I've really loved is that it's completely self-contained, it's self-paced, lots and lots of community support and resources in there. The challenges are really fun and interesting. So you might want to grab a screenshot of this if you haven't had a chance to go through the courses yet. These are the ones that I recommend in this order for you to start with. If you don't have any programming experience at all, then definitely start with the Intro to Programming course and then the Python course as Gabriel recommended, because everything else is built on Python, although it walks you through what you need to type. So you can jump in without it, but you'll definitely need that as you progress through your training and your pathways here. Lots of additional stuff. I love how all of these courses are very short. Each one is about 4 hours. I've been able to chip away at them just a little bit at a time. And it feels good to be able to complete something. So I've really been enjoying that. And if you jump into these, you find any of them particularly useful, please share them in our Slack channel with our community, with your friends. We would love to hear what everybody's working on for that. So even though the month is over, learning never ends, right? There's always more that we can study and we can work on. So next steps after if you were able to do this whole study jam, you've been able to complete all the courses that we were offering, there's lots of things that you can do next after you finish just that introductory stuff that Kaggle offers. You can practice with some of those challenges. Gabriel, you mentioned the Titanic challenge. That's one of the ones that we have listed in here. The home prices competition, digit recognizer, lots of fun competitions that you can do in there. You can even win prizes. I don't know. I think that's really cool that you can practice and have some fun doing those. You can also get certified. Google has machine learning certificates that you can sit for the exam. You can earn a certificate. As Gabriel talked about earlier, there's a TensorFlow certificate that Google offers. There's also a Google Cloud Professional ML Engineer certification that you can get. Or you could become a Google machine learning Google Developer Expert. As Gabriel, you can present on stage elsewhere in the planet in the future. It's a great community. Gabriel, do you want to take just a second to talk a little bit about what the GDE community looks like for you?
Sure. Okay, the GDE community is a community created by Google. It finds people all over the world that are considered by them experts in their solutions. So this goes from machine learning to TensorFlow to Angular to maps and specific technologies from Google. And we create a community where Google supports us to help the community. So the Google community helps us to support our local communities and our worldwide communities by sharing in talks, sharing articles, sharing videos. And there, if you want, I have a link here with all the GDEs. And these are people that Google finds as experts, and they share a lot of good content in the internet. So if you want to check out some content by some GDEs, I can send the link of on where you can find those people. and you can find those people in your country or your city. You just have to find the Google or the map.
Thank you. Yeah, all over the world. And it's a great community. And even my involvement as a Google Developer Group leader, Google has provided so much amazing support to me as a community leader. Events, conferences, trainings, opportunities, lots of really it's a really great ecosystem is what I'm trying to say. And it's great to be part of that environment, even as a volunteer working for other organizations, but supported by Google as part of this global community, I think is really cool. All right, so last thing before we go, I have some prizes to give away. I actually have the Kaggle book. Let's see, let me share my screen so I can show you what prizes we are, the fun prizes we are offering today. And again, this is, thanks to everybody who has been hanging out with us today and all month long. So we've got the Kaggle book. This one will help you to really up your competition game. So if you're into Google competitions, this book will really help break down your strategies and techniques and stuff for winning those Kaggle competitions. So that's pretty fun. This is going to be an Amazon Kindle format book. So unfortunately, it's only available to folks here in the US. But it's a really great, I think it's really fun. So that's one prize that we're offering. And then our other prize is this complete data science bootcamp on Udemy. It includes Python, machine learning, statistics, math, a whole bunch of stuff. It's everything that you need to know to kind of get up to speed on what machine learning is and kick off your career. So if that's something that's interesting to you, we have these prizes that we're giving away as well. And I have our fun wheel of names. So let me share the correct tab so you can see our wheel of names. Here we go. And I'm giving away 2 prizes. So Laurel, thank you. Please send me a direct message in the chat with your email address so that I can send you. You can't get the Kindle book, but you can get the data science course. So I'll send that to you, or you can give it away to someone else. But thank you so much. Again, just drop me a DM with your email address so I can get that to you. And then our next person, lucky drawing. Oh, I can't even tell where the line is. Who is it? Alessandra. Awesome. Congratulations. So again, drop me a direct message in the chat with your email address so that I can get you your prizes. Also, I have a feedback form. I'm sending the link to the feedback form. So please, if you have a few minutes, please take a few minutes to fill out our feedback form. I will draw one more winner from the feedback form, and want to make sure I give out these prizes. So again, thank you everybody for participating with us today. Gabriel, thank you so much for speaking, for being with us today.
Thank you for the opportunity.
This video is going to go up on YouTube later. Yeah, thank you. All right, and that's a wrap. So thank you so much, everybody. Have a wonderful rest of your day today, and enjoy, October. What is October going to bring? I don't know. Take care, everyone.